Industrial environments can be some of the most extreme on the planet, from high-pressure systems to hazardous chemicals, scorching temperatures to volatile materials. These operations demand robust, reliable and highly precise technologies to keep everything running safely and smoothly. Whether it's about measuring emissions, optimizing efficiency, improving energy use, or improving plant-wide safety, modern instrumentation is playing a quiet but critical role behind the scenes, and even the smallest technical innovation can create a massive impact. It is these small but high-impact technologies, or as I like to call them, the hidden heroes, that we are going to be looking at next. I want to find out more about these small technologies. How are they created? Who comes up with them? How are they tested? What could the future of smart instrumentation look like? To answer these questions, in this bonus episode, we are joined by Shanthala Kamath, R&D Corporate Executive Engineer in ABB Measurement and Analytics, as we explore the role of research and development, R&D, in this field. I'm Fran Scott, and this is the Process Automation Podcast from ABB.
So the research and development engineers, their focus, as the name suggests, is to use their skills and technology to design and develop products. So a lot happens between conceptualization of a product to the time where it is being used by the end users. Now, if I want to look into a typical workday for an R&D engineer, R&D is teamwork. So a workday often begins with planning and aligning with others. Then the day is peppered with design and development activities such as working on a prototype, documenting, doing detailed design, investigating problems, and of course, most importantly, collaborating with cross-functional teams. Because R&D doesn't happen in its own vacuum. You need to collaborate with cross-functional teams, with product managers, with service and sales, with customers. So all that are part of an R&D engineer's day. However, there are some non-routine days that typically peak the adrenaline in an R&D engineer. And these are days when your products are being tested by real users. You hold your breath, hope everything goes well because you have done your work. But ultimately, a product is successful when the real users start using it and really appreciate what it is doing for them.
But so rewarding to be able to see what you've made actually come to fruition. And those testing times must be so nerve-wracking, seeing the product that you've worked on for so long in the hands of someone else. It's so exciting.
Yes, it is. It is, if you take the analogy of sports, it's when the last goal happens.
And so where does an R&D engineer source their inspiration from for these technology developments?
Yeah, that's such a great question because inspiration comes from very diverse sources. The inspiration is usually because of human curiosity and instincts. Take, for example, the non-invasive temperature sensor, NINVA, for example. So the inspiration comes from human instincts and curiosity. Is this glass of water cold? And I don't really need to dip into it. I can feel it from outside. So the same concept transfers to a process fluid pipe. We have developed models to predict the process temperature based on the surface of the pipe. So inspiration from just basic curiosity, but the product is a game changer. See, technologies such as NINVA are developed in our own R&D organizations. But sometimes in industries, we do R&D effort across the industry at an industry level with various vendors working together. And this recently happened with Ethernet-APL. So the inspiration for Ethernet-APL technology, you look around. If we observe how everything else in the world is connected, Ethernet dominates the world of connectivity. Now, why didn't we have it in these harsh industrial environments? So it's a combination of curiosity and observation.
So with the Ethernet-APL, you're saying that before this innovation, you couldn't have Ethernet in these harsh environments.
That is right. And we had really low-tech, domain-specific technologies. So see, Ethernet-APL gives you 10 megabits of data. The predominantly used technology today gives you 1,200 baud. That is 1.2 hertz of data speed. Imagine these huge Coriolis meters. They measure so much. Getting them one at a time is painstaking. Previously, if you needed to configure the instruments, you needed to have specific handheld tools, specific software, download the drivers. The engineering effort to look into the instrument, make a configuration was complex, it was time consuming. And now, you can treat your device like any other Ethernet appliance. So Ethernet, it's really bringing that connectivity, high-speed connectivity to even the harshest of industrial zones.
Brilliant. And in a way, it sums up the role of an R&D engineer, that you're not just dealing with the obvious problems, but you're observing the mechanics as a whole and the systems as a whole and saying, hang on, why are things done that way? Could we do them different? And then coming up with ways to do them different, which sometimes ends up being the complete game changer.
Absolutely.
What does success look like to a research and development engineer?
Yeah, see, I spoke about this journey from idea of a product to the product being in the hands of a user. And this journey is often long. It has detours, it has cross sections, and it has dead ends. But see, most R&D activities, R&D is a very well-structured machine. R&D activities are segmented into meaningful milestones with good outcomes. So achieving each one of this is a success in itself. But this is not simple. And often we don't see the results that we want to see. One might call it as a failure. But then most often engineering training creates a mindset of learning. So if you ask an engineer, they learn more from their failures than from their successes. So engineering is all about problem solving and innovating. And as I said, the ultimate success is, of course, when a product really does well, does its job, and helps lead us to a better world.
Absolutely, because let's not forget what it is that you are developing is, yes, it's small technology, but it's making a huge difference. And you've worked 25 years in this sector. And so the changes you must have seen over those decades are huge. And so what emerging trends do you have your eye on for inspiration for the next developments?
It has to be generative AI. So if I look at the rest of the world, generative AI is happening. It requires huge computing resources. However, if you can encapsulate and run it on, let's say, even lesser capable compute environments, what's the possibility?
And so to finish, Shanthala, what inspired you to get into R&D? And what would you say to someone who's listening to this and thinking, do you know what? It might be a career for me. I'm a problem solver. I like testing out things, trying to figure out the solution. What would you say to someone that's thinking of going into this career?
See, my entry to engineering profession was a natural extension to my education in instrumentation engineering and my love for physics. So sensing and product development came naturally to me. So making taking something from a concept. If you have an idea, how do you bring it to life? It happens through collaborative work. You're solving problems. You're in fact inventing and innovating. So there's a lot of things, but creativity and problem solving become the cornerstone of a R&D engineer.
Absolutely. You are the modern day inventors that are tinkering away in a very professional setting, but tinkering away to make these inventions that go on to change the world.
Absolutely. Yes.
A huge thank you to our guest, Shanthala. And if you want to get involved and join us as an expert, follow the link to ABB's website in the episode description, where you can let us know your domain of expertise. I am Fran Scott, and the Process Automation Podcast is a fresh air production for ABB. Follow now for free wherever you get your podcasts so you never miss an episode.